Okay, so we'll talk about multiplicities here a little bit. The behavior of the y variable near the vertical asymptote can be summarized as follows. Look, come over here. If the thing that makes the denominator, the zero that makes the denominator 0, if that's got an odd multiplicity, we're going to have one up and one down. If it's there twice, x minus 3 times x minus 3, we'll either have both up or both down, depending on if there's a negative involved. So look, the behavior of the y variable near vertical asymptotes can be summarized as follows. If the multiplicity of the 0 in the denominator is odd, then the behavior is it will go one up towards the vertical asymptote and one down towards the vertical asymptote. If the multiplicity is even, the y values on either side will go both up, like in the parent function, or both down if there's some kind of a negative involved. Okay? Now those are things I'm describing are close to the origin or near the origin. Those things describe local behavior, which means close to the origin. The next part is on end behavior. So when I start transferring over to talk about horizontal asymptotes and something coming up called an oblique asymptote, we're referring now to end behavior, not local behavior. Okay, so this definition is going to be a little weird for you, but just work with me for a second. Let L equal some number. If, watch what I write here, f of x approaches L as x approaches negative infinity. If the y values are going towards some number as x approaches negative infinity, and if the f of x approaches L as x approaches positive infinity, so if I go left or right, the y values are approaching some number, then y equals L is called a horizontal asymptote. A horizontal asymptote. Okay, I'll give you a second to write that down. L is a number like 10. If the y values are going close to 10 as x goes towards negative infinity, so I'm going towards negative infinity and my values are heading towards 10. And I'm also heading towards 10 as x goes to positive infinity. So either way I go, I'm heading towards 10. That's called a horizontal asymptote. Let me go back to the first page here. And look, as x approaches negative infinity, these y values are getting closer and closer to 0. And as x approaches positive infinity, these y values are approaching closer and closer to 0. So we call y equals 0 a horizontal asymptote. Okay? Go back to the last example we did, which was this one. Since we moved up 2, and we went up 2, in both directions, as x approaches negative infinity, the y values are coming down from above y equals 2 and getting closer and closer to 2. And as x approaches positive infinity, they're coming down and getting closer and closer to 2. So, for that reason, name the horizontal asymptote, it would be y equals 2. Okay? And then we have one more of these weirdo possibilities. What if L isn't a number? Okay, hang on. Just follow along for a second. If f of x approaches ax plus b as x approaches negative infinity, go ahead and write that down. If f of x approaches ax plus b, and if f of x also approaches ax plus b as x approaches positive infinity, then y equals ax plus b is called an oblique or slant asymptote. Instead of having a horizontal asymptote, you get a slant asymptote. So as the graph goes like this, it won't go like towards y equals 0. It'll turn around and go towards that line. See what I mean? It'll end up looking like that. And on this side, if the line's going down here, then maybe it'll end up looking like this down here. Okay, we'll see several of these. So if that doesn't make sense to you, it's going to be okay. Graph the following on your graphing calculator and sketch what you see. So go ahead and put that in the graphing calculator and do your best to sketch it, and we'll talk about what happened.